Hey everybody, and welcome back to the third installment on limits of transcendental functions in calculus. And this portion of the videos are going to switch gears into dealing with trigonometric functions. Now, a lot of the things that we're going to be dealing with the trig stuff are going to require you to have some understanding of the unit circle, all right? So here I provided a copy of the unit circle in the notes just to give you some kind of reference. I know it's not very big and it may be a little difficult to see depending on what you're looking at, but the unit circle is something that if you haven't committed to memory, you are going to benefit by committing it to memory. It's just going to be one of those things you're going to have to remember. Now, taking a look at what we're seeing here, this is where we're going to take some functions and we're going to just do some direct substitution. So here we have an angle theta that we're going to be evaluating these two functions for. So cosine of 2 theta over theta and 3 sine squared theta as theta approaches their respective angles. Here you're going to just go with the direct substitution and refer to the unit circle as you need to. Oh, I don't need that. So here, when you plug in the pi over 3 into the numerator, the 2 and the pi are going to multiply together to give you 2 pi over 3. Well, 2 pi over 3, if you're looking at it on the unit circle, is in quadrant 2 at 120 degrees, and it gives us a cosine value, the x-coordinate of -1/2. So that's why in the first step to the second step, the numerator changes to -1/2. Now the denominator of pi over 3, it doesn't really simplify with anything. It just stays pi over 3. So you can leave it as -1/2 over pi over 3, or you can simplify it to -3 over 2 pi. The next one is we go to pi over 2. Pi over 2 is at a 90-degree angle on the unit circle, so the sine value, the y value, is going to be 1 in this case. So I'm going to say 3 times the sine of pi over 2 squared. Well, the sine of pi over 2 squared simplifies to be 1. 1 squared is still 1. So 3 times 1 simplifies overall to be a 3. Now here, just like what it's telling you here in some polynomial functions where the function is not yet defined, a limit will still exist. And here, taking a look at this example, evaluate what we have here using direct substitution. Now in this case, if you take the 0 and you substitute it in for theta, sine of 0, if you look at it, 0 degrees is going to be a 0. And cosine of 0 is going to be a 1. So those are going to replace sine of 0 and cosine of 0. And those are just coming directly off of the unit circle. Specifically, we're talking about at 0 degrees, we're talking about those two values right there, where this is cosine and this is sine. So we're just substituting those numbers in. And so 0 minus 1 in the numerator is -1. 1 squared in the denominator is 1. So -1 over +1 simplifies to be a -1. And that's what the limit will be for that function as theta approaches 0. Moving on, in our notes, if the screen will cooperate with, too many times. Sorry, went too many times. I don't know why it's wanting to work one. There we go. Sorry, I don't know why it's giving me such a hard time turning the screen. But here, this is definitely something that you want to take a look at when you're not working with a graphing calculator. Now, the graph is provided for you, but we definitely need to remember how the algebra and the trigonometry are going to work hand in hand. So we're given a function, and you can see the function f of 2, f2 of x is equal to sine of x minus 1 in the numerator over cosine of x squared in the denominator. Well, how can you algebraically simplify this? Well, we do have to remember a little bit about trig identities. So back in pre-cal, there should have been some material that you covered called trig identities, and the very first one that you looked at was sine squared of theta plus the cosine squared of theta is equal to 1, hence the identity. Well, algebra says I can take the sine squared of theta from the left side of the equal sign and move it to the right side of the equal sign through subtraction, giving me cosine squared theta is equal to 1 minus sine squared theta. Well, going to the function that we have, I can replace the cosine of x squared is what they have in the denominator. I can replace that with the 1 minus the sine squared of theta, or sine squared of x is what they're looking at. And if I factor the 1 minus sine squared of x, I get what I have in the denominator on your screen, where it has 1 plus sine of x over 1, or times 1 minus sine of x. So the 1 minus sine of x in the bottom and the sine minus 1 in the numerator, those will simplify to be a negative 1. And that's exactly what I'm going to do next. So I get a negative 1 over sine of x. Now, we don't know what x is being evaluated for. We're not substituting an angle measurement in there, but that is how I would simplify the expression using some algebra with my trigonometry. At this point here, I would like you to attempt working out the two examples that you see on your screen here, example A and B. Just see if you can refer back to what you know about trigonometry. Can you simplify them with a little bit of algebra before you evaluate them with the given angles? So go ahead and pause the video, try working these two out, and when you're done, hit play and see how your answers look with mine. All right, so hopefully you have some answers here, and I'm going to just run through what I have. And oh, look, there's one more here that I didn't realize was there. So we'll go ahead and do that when there's a bonus for you, unless you've already done it. So here we have 2 times cosine of theta times cotangent of theta. Well, cotangent of theta, there we go, is just the ratio of cosine over sine. And so what you're going to see in the numerator is the 2 cosine of theta and the cosine of theta, both are in the numerator. Those are going to combine together as something squared. And here, if you squared them already, that's fine, but I went ahead and substituted. And now here I'm simplifying where I'm going to have cosine of pi over 2 squared. Now, continuing through, what we're going to see next, go to pi over 2 on your unit circle, and you're going to see that the cosine value at that point is 0. So 2 times 0 squared gives you 0 in the numerator. 0 in the numerator. Why isn't it showing up? How interesting. Okay, well, I'll go ahead and just write it in there, I guess. I don't know why it's not really showing up. So here I would have the limit as x approaches pi over 2. 2 times 0 squared would give me 0 in the numerator over 1, which simplifies to be a 0. And that's what we would get for the limit of the first function. Going to the second function, again, we're going to recognize that tangent is the ratio of sine over cosine. So I replace the tangent in the denominator with that ratio. Now, simplifying here, I am going to take the denominator and multiply it by the reciprocal to the overall numerator and the denominator. And we'll see that, this sine of theta and this sine of theta simplify to be 1, this cosine of theta and this cosine of theta simplify to be 1. And additionally, this sine of theta and this sine of theta would also simplify to be 1, and all I'll be left with is cosine squared of theta. And so that's what we have. There we go. Next. So now I can evaluate this as pi over 4. Refer back to your unit circle. Substitute. And pi over 4 is that 45-degree angle, giving you radical 2 over 2. So I square that value, and I get 2 over 4, which simplifies to be 1/2. Oh, hey, look. Now it shows up over there. All right. So let's take a look at the one on the bottom. Here, taking a look at this one, Cosecant is the inverse of sine, so I can replace the cosecant of theta with 1 over sine of theta. And if you notice, sine of theta times 1 over sine of theta, those are inverses of each other. They should simplify to just be a 1. So 1 over 3 theta, substitute pi for theta, and I wind up with 1 over 3 pi. And we're done with that one. So finally here, this is where we're going to close up this portion of the video. Have you discovered a pattern in all of this? Well, first you're going to try direct substitution if you can, but if you and you should see one of 3 things. You either get, some nice number that you can say that is what the limit is. You'll get something over 0, giving you our undefined values, and then you could possibly get an indeterminate form, although I don't think we saw any indeterminate forms in our material. So I'm going to go ahead and stop this video here, and we'll pick it back up in video part 4 next. And if you have any questions about anything you saw in this video, please, by all means, let me know, and I'll be happy to help you out. Send me an email, come to tutoring. But until then, guys, thanks for watching. Take care. See you soon.